Hello everyone. So today we're going to go ahead and learn how to combine it and compress logarithmic expressions. So let's go ahead and begin with the warm-up. So go ahead and title this on your notes, 3.4, combining and expanding logarithmic expressions. So go ahead and pause the video, give these a try. Okay. So whenever you see a negative as the exponent, keep in mind that is a property of your exponents. That pretty much tells you that you can go ahead and bring that to the denominator. Is pretty much a reciprocal, so 1 over a. The next value right here, number to a 1/2 exponent. 1/2 exponent, that is the same thing as saying square root of that value. Oops, that's a horrible a. Square root of a. Okay. Last but not least, a number to a 0 should be 1, as long as it is not 0 and infinity, right? So let's go ahead and begin. We have this 1/4 to -1 value, so that's going to give us the reciprocal of 1/4, so it should be 4 over 1, and that just simplifies to 4. Okay, not that bad. The next one says 16 to the 1/2 exponent, so I'm going to go ahead and rewrite that to be square root of 16, and I can simplify that. That will give me a positive or a negative 4, right? Because 4 times 4 gives me 16, and -4 times -4 gives me 16. So make sure you include both of them. Okay, so here we have 2 to the 0, so the numerator is going to become a 1, and the 4 stays the same. It's going to stay in the denominator. So hopefully these didn't bother you too much. It should be mostly a review, round root 2, and a little bit of properties, right? If not, you can gladly look at the video that we recorded last week. Okay, so let's go ahead and look at a week at a glance. So today's notes won't be as bad, but they will be due on Wednesday at 5 p.m. So if you do have questions, please always send me a Teams message and I'll help you out, or drop it in the comments and I'll help you out as well. Okay, Tuesday, I heard you guys' feedback. It's too much homework, so I went ahead and I decided that tomorrow there won't be any homework, as long as we do put in the work on Tuesday, right? And Wednesday, Thursday, and Friday, we'll still continue learning about logarithms and preparing for our exam, which should be on Tuesday as well. Next Tuesday, okay? And I went ahead and put a friendly reminder that on Wednesday, 3.4 is due, and this one, 3.6 will be due, okay? Alrighty. Oh, before we get there, is tutorials on Tuesday at 4:15 to 5, okay? But I'm always available on the Teams chat, email, or text, and I will gladly help you out. Alrighty, so today we're going to go ahead and learn about these properties of combining and expanding logarithmic expressions. You can also find these by, they call them compression or condensing as well, but they mean the same thing. Okay, for notes for today, make sure you go ahead and write these down. So go ahead and pause the video and write these down on your notebook. So let me go ahead and give myself more space by hiding these panels. That's better. Okay, so go ahead and pause the video, write these notes down on your notebook. Okay. So today the main part of this lesson is called the product rule, the quotient rule, and the power rule. Okay, so this works as long as my values for the base b, r, and s are positive real numbers. Okay, and of course we're gonna have b equal to 1. Alrighty, so the first one that I'm going to go ahead and talk about, I'll do it in green. The first thing that I'm going to talk about is the product rule, meaning whenever you have two terms inside a logarithm, you can go ahead and make that one logarithm into two by going ahead and by doing addition of the logs. So two things to notice here. This log will become two logs if and only if they have the same base, okay? So from here, if you want to go ahead and add two logs with the same base, it's the same thing as multiplying whatever is inside. So this little r and this little s multiply. Okay. All right, let's go ahead and try the next one. Let's read. Division of two terms inside a log. So division is the same thing as the same two bases, right? Logs, the same two bases, but they're being subtracted. Okay. So keep in mind this right here. This r will be on the numerator, and this s right here will be on the denominator. Okay, and we'll do some examples right here about what I'm talking about. Okay, last but not least, and I feel like this is what students struggle the most, and that is the power rule, meaning the exponent right here is your coefficient. So this coefficient came and became the, oh, sorry, the x1 became the coefficient. So keep in mind you could do whichever one you need. You could bring it up to be the exponent, or you could bring it down so it could be the coefficient. Okay. So it sounds difficult. It really isn't. And we can go ahead and do some examples right now. Okay. All right. So the first thing I want to go ahead and clear up is the properties of these rules. So the exponential rule, so the power rule. So keep in mind, if you have the c, you can go ahead and make it become the exponent, like so, right? So let's go ahead and practice them. Okay, so go ahead and try these out. Get this coefficient, and it will become the exponent. So what do we have? We have a log, and then x to the 1/2. Okay, that looks a little funny to me, because we know how to write that 1/2. Keep in mind, we did it on the Arduino, x to the 1/2. Same thing as saying square root of a, right? So I'm gonna go ahead and write it prettier. Log square root of x in this case. Okay. Go ahead and try the next one. This one looks like a little bit more scary. Remember your algebra. So if I have an well, let me go ahead and do it. Let's see. Let's call this x. A over b. Sorry about that. This will be the same thing as saying the b will go over here, and the x stays as the base, and then the a will be the exponent. So the same thing happened with the 2 right here. This right here, the square root is actually a 2. So keep that in mind. So this one shouldn't be that bad. You get the coefficient. It becomes exponent, so it should be ln of the following. X, the cube root, and the exponent is 2. Really small, but hopefully ln cubic root of x squared, like that. And that will all be in your parentheses. So it looks a little messy, but right now we'll go ahead and get more practice with the addition and the division. Okay, so let's go ahead and get some examples. So go ahead and pause the video to write these down and give it a shot. You know that addition is multiplication. So this one is telling us to expand using the product rule. So we're probably going to use this one. Remember, if they multiply, that means you go ahead and add them together. So right here, I'm multiplying them. So I'm going to go ahead and write 2. This is the same thing as saying log parentheses plus a parentheses, because it's multiplication log of something, right? I saw that there were multiplication, so therefore I had to add a plus sign. Then I'm going to go ahead and see that the first term is going to be the one that goes here. So this one's going to be a 3. And the next one, my x, is going to be right here, which is an x. So that's all you have to do for stuff like this. So this one wasn't that bad. So go ahead and pause the video and try the next one. So I got the next one. It says logs are being multiplied by 6 times x times w. So it's 6 plus, right, my log times my next term, which we said is x, plus my next term, which we said log of w. So easy peasy, right? Yeah, the same thing that we saw here, guys, we also need to be able to see it backwards. So if I see all these logs being added, I should be thinking, oh snap, I can compress this into being only multiplication, right? Okay, so let's go ahead and try that. What is to happen if we have all of these right here? That we're gonna go ahead and compress it. So go ahead and pause the video. And give these a try. So notice they're all the same base, right? And they're being added. So therefore, this should be only one ln, and everything inside should be multiplied. So x times my next term, which is also x, times my next term, which is 3x. And don't be scared to combine like terms, guys. So this should be ln x times x times x, that is x cubed, and the 3 stays as the coefficient. So we have something like that as our solution, right? Let's go ahead and try the next one. Again, I see a plus sign. and the logs have the same base, right? In this case, there's no base, so we know it's 10. So it's going to be log, and all of this is going to be multiplied together. So 2x times x plus 3. And from here, guys, we can go ahead and distribute this. So we have 2x that distributes times the x, the 2x that distributes times the 3. So I should have a log 2x squared, and then 2x times 3 gives me a 6x. So this should be our solution, right? Okay. As always, guys, if you do have questions, please message me. Okay, let's go ahead and try the quotient rule, right? So what happens if there is a subtraction? Oh, and we have an exponent right here. I mean, a coefficient. So what I like to do, guys, is I like to go ahead and get these values right here and start by getting them to be the exponent. So automatically I have an ln x squared minus ln x plus 7. If they're in parentheses, guys, don't split them up because that is its term on its own. Okay, so automatically, guys, when you see this minus sign, you should be thinking, oh snap, I need to start dividing. So I'm going to go ahead and put a little fraction right here. And the first term right here stays as the numerator. So it's going to be x squared. And the second term all together, x plus 7, goes on the denominator like so. So these ones aren't that bad. Okay, so let's go ahead and start mixing stuff up. So go ahead and give this one a try. So expand the following logarithm. So go ahead and pause the video, give this one a try. So I have a log with a base of 2. I see a subtraction. I'm sorry, I see a division. So I should be thinking about subtraction. And all of this right here, guys, all of this stays together, x plus 5. Okay, and I see a square root. So I have a lot of stuff going on. I'm going to go ahead and rewrite this to make this a little prettier. Log base 2, like so, and I got x to the 1/2. Okay, then I got an x plus 5 in the division, right? So automatically, I should be thinking, oh snap, I need to be writing this in 2 separate terms. So I'm going to go ahead and start doing that. So I should have a log, right, base 2, x to the 1/2, minus, because it's division, a log base 2, x plus 5. So far, so good, right? Now, as much as I want to tell you, oh, this is good enough, well, keep in mind this 1/2 right here can still go to the coefficient. So this is going to be 1/2 log base 2 x minus log base 2 x plus 5. And that should be your solution right here. So these aren't that bad, even though they look a little tricky, right? Alrighty. So let's go ahead and try this one. So this one's gonna have a variations of stuff. So go ahead and pause it and give it your best shot. Okay. So we have all these numbers, right? We have these coefficients of 1/2 and this one right here of 3. It's being added to this. So what I want you to know is that we're gonna go ahead and do it from left to right, and we're gonna do all the coefficients to become exponent because of the power rule. So it's going to be ln of x to the 1/2 minus ln of w to the 3rd. Keep in mind, guys, that minus sign only told me it was division. I'm not carrying that negative with me. All right, and the next says that ln to the w. Okay. So let's go ahead and continue. So I'm going to go ahead and rewrite this. So the 1/2 exponent, or x to the 1/2, is the same thing as saying the square root of x. So I should have ln square root of x minus my ln of w cubed plus ln of w. Okay, so let's go ahead and do the first 2 terms that says ln of x and minus ln of w cubed. So I'm going to go ahead and say ln, right? Because everything here has the same base, divided by, so I should have an x squared on top. And that's going to tell me that this ln of w to the 3rd is right here in the denominator because of the minus sign. Keep in mind that w stayed positive. Okay, and the last part, dilemma, this plus w. So notice, this plus w it's multiplication. So it's going to multiply to the first term, okay? So it's going to go ahead and be right here. Okay. So now keep in mind this right here, we can go ahead and simplify it. Also depends on what pretty much your teacher is requesting. I'm going to go ahead and ask you guys to continue to simplify this. So if I have square root of x on the numerator, I have a w on top, right? And I have 3 w's on the bottom. So if you were to think about it algebraically, we have w, 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 right? Like websites. And we have a w in common in the numerator and denominator. Those will simplify to 1, right? So you should only have a w squared in the numerator. Okay. In class, we brought up an interesting point. What is to happen if instead of it being, let's go ahead and copy it like right here. Instead of it being ln of square root of x minus ln of w cubed, what if it, instead of it being a plus sign, right? Instead of it being a plus sign, the last term, it was another minus sign. So minus ln of w. So I really like this question. So keep in mind, anytime you see division, anytime you see subtraction, you should be referring to division. So it's going to be ln. All of this is divided, so I'm going to have division right here, the square root of x. That nothing changes with this. This stays in the numerator. This one right here stays in the denominator, so w cubed. But here is the main concern. What is to happen when I have this other minus sign right here? So if you had that same concern, awesome. But honestly, nothing bad happens. So from the other example, we had multiplication in the numerator. Whenever you have the another subtraction followed by a subtraction, so this was our first subtraction, this was our second, all it means is multiplication, but in the denominator. So this w is going to be with the denominator. So I should have ln square root of x divided by w to the fourth, because w cubed times w is w to the fourth. Okay. So keep that in mind, guys, of how it's going to multiply. So if it's a plus sign, it affects the numerator, and if it's minus sign, it goes to the denominator. Okay. I have a little meme for us here. So I understand that it's a little difficult to wrap our head around this, but addition of logs is multiplication and subtraction is our division, right? So here we go. For homework, guys, this will be due on Wednesday. So I gave us about 7 questions, I believe, about compressing and expanding these logarithmic functions. So if you do need help, guys, please message me. If not, I have tutorials on Tuesday at 7:15 at 4:15 to 5 p.m. Okay, awesome. That is all that I have for us today. As always, guys, it was a pleasure. Thank you.